So we obviously know that balloons are pretty fragile. You can't keep them near sharp objects, and you obviously cannot usually stick them under a flame. And as that video showed, it's pretty easy for it to pop under the pressure of the heat. However, when you add water to it, it becomes fireproof. So this is actually, if we think about why, it's actually because of the thermal conduction that happens. I think that, first of all, water is a great substance to soak up heat. It's a really good conductor. And so I think when the balloon is filled with water, the water allows the molecules of heat to distribute quite quickly, and it spreads the water. So as the water closest to the flame heats up, it'll begin to rise, and cooler water will replace it at the bottom of the balloon, and that's how it'll continue to cycle because of the fact that everything likes to move from the least amount of more pressure to least pressure, like in osmosis and other things, other processes that we know about. So this process would just keep happening, and then I'm sure eventually the balloon would heat up. I'm not really sure, and I'm going to avoid trying to find that out today because I'm in my kitchen, but that's basically the process of what I think is going to be happening, and kind of explaining it, because as things heat up, the molecules move faster, their energy and vibrations increase, and it's kind of how the heat starts to spread and move. So I already tried to make this video, and I made a huge mess. So I have my air balloon already filled up, and I'm going to try one more time to blow up the water balloon on camera, but we'll see. Alright. And I'll just put a little extra air into it. These are my Halloween balloons from my first experiment, but they come in handy, so. Alright. It's kind of hard to tell how much water's in there, but hopefully that'll be enough. First, I will demonstrate how quickly it heats up for the air balloon. So this just has no water in it. Okay. Alright. And now this one will be the water balloon. It's pretty cool. Cool. And you can definitely see that there's some like soot on it, which I believe would be carbon, but the balloon itself is not actually damaged. So the experiment works. And let me just check my notes, but like I said, it's because the water is absorbing more of the heat than the actual rubber of the balloon. Okay, so I guess the real question I have is if I were to keep going, if it would explode after all, because then the temperature of the water is equal throughout, and then it has no other choice to heat, which is kind of how I would think heating up a tea kettle works. Like, it takes a while at first, but the hot water eventually is going to get everywhere and then hit a point where it begins to boil. So that's this week's experiment. Hope you enjoyed.